In this section of intermediate algebra, we're going to be covering linear inequalities. So this ought to be fun. And I know you're excited. Okay, so let's go to the whiteboard here. So finding the solution to a linear inequality is much like finding the solution to an equation. So let's start off with x plus 5 is greater than or equal to 10. So I want to find all the numbers that I can plug in for x that makes this true. But this number over here will be either greater than 10 or it could be equal to 10. So we solve this just like we'd solve if this were just an equal sign here. However, there's a couple exceptions. Now what I'm going to do here is I'm going to go ahead and subtract 5 from both sides. Rewriting the inequality sign. So 5 minus 5 is 0, so we're left with x is greater than or equal to, and this will become 5 over here. 10 minus 5 is 5. Now let's go ahead and draw a graph. So I'm going to attempt to draw a straight line. I'm using a tablet and a pen, so this is not exactly easy to do. I'm going to go ahead and label, just label 0 on the number line here, and I'll just say, okay, 5 is right here. How's that on the number line? Now, because this is an equal sign here, we're going to include the equal. So I'm going to put a filled in dot here because we're saying that it includes 5. And then everything greater than 5, greater than or equal to 5. There's another way of writing this solution, and I'm going to go ahead and state that. We can also write it like this. This is interval notation, where I have a bracket, which means I include 5, and we're going out to infinity, and we put a parentheses here because that means that we don't ever reach infinity. So this is an interval notation. So no matter what number I pick in here, when I plug it in here, this will always be greater than or equal to 10. And you can test that out yourself. You can take 7 and plug it in, and you will see that that will be greater than or equal to 10. Alright, let's look at another one here. We have x minus 9 is greater than negative 2. So I'm going to add 9 to both sides. And we're left with x is greater than 7. Now let's go ahead and draw a graph. So attempting to draw a straight line here, that's not too bad. And I'm just going to label 0 here, and we'll say 7 is here. So you notice this doesn't include the equal sign, so I'm going to put just a circle here, and then it's everything greater than 7. Now our interval notation will be a parentheses. Now you notice I put a parentheses here, indicating that we can't use 7, okay, and it goes out to infinity. Okay, so this is going to be a problem for you to find the solution, and I'll actually help you out here. Right, you write the interval notation, and you want to also make sure that you draw the graph. So I'm going to label 0 here, and we'll put 8 here, and remember it includes it. Okay, so you try to figure out how to get this. We are working linear inequalities, and intermediate algebra. So let's look at this inequality. We have 7x is greater than 0. So we want to find the solution set and draw a graph, right interval notation. Well, this is actually pretty simple here. What numbers could we plug in for x to make this true? Well, we're going to go through the algebraic steps, and I'm going to multiply both sides by 1/7. So 1/7, or I should say, 1/7 times 7 is 1, right? So that's what we're wanting. We're wanting a 1 in front of this x here. And 0 times a number is just 0. So this says all values greater than 0. So let's go ahead and draw a graph, or at least attempt to draw one anyway. So I'm going to label 0 here on my axis, and notice this inequality doesn't include the line underneath, the equal to. So I'm going to just put a circle here, an open circle, meaning we don't include the 0, but it's everything greater than 0. And if we were to write this in interval notation, we would write it just like such. Remember, this parenthesis says that we don't include the 0 here. Alright, looking at another example, how about negative x is greater than 6? So in this particular case here, because we have the negative, we're going to multiply both sides by -1. Now, since we multiply by negative, we're going to flip the inequality. So that's one of the rules that you have to remember, is to flip the inequality only when we multiply by negative. So -1 times negative x is just x, and so we're left with x is less than -6. Let's draw a number line here, and I'm going to go ahead and just put -6 here on the number line. We'll say that this is 0, and we do an open circle and everything less than -6. And if we were to do this in interval notation, right, a parentheses here because we don't include -6. Okay, so let's find the solution to this inequality. I'm going to subtract 1 from both sides. And so now we're left with 2x is less than or equal to -8. Then I'm going to multiply both sides by half. So I guess I'll just write that in right here. And we're left with x is less than or equal to, so a half of 8 is 4. So we include the -4, so I'm going to put a filled in circle here and everything to the left of -4. And of course we can write this in interval notation. And this is a bracket here because we include -4. So this is going to be your problem to work, but I'm going to be nice enough to give you the solution. And remember that you also want to draw the graph. Right, x is greater than -12. Doesn't include it, so we put an open circle and everything to the right. So try to manipulate this thing around so that you get the proper inequality in the end, or the solution. Okay, we're working linear inequalities in intermediate algebra. think something I might have not mentioned in some of my other videos, and that is I do have a website called mathfix.com, or however you want to pronounce that. That's PHIX. And PHI is the Greek letter. Okay, whatever. So anyway, I've put together a website. You'll need to click on Intermediate Algebra and then go to Linear Inequalities for some exercises. Good stuff. Okay, let's see. Here's a good one here. 2x plus 15 is going to be greater than or equal to negative 3x. So the first thing I'm going to do here is, I believe, let me go ahead and take this negative 3x over to this other side, and we're going to do that by adding 3x to both sides. So 2x plus 15 plus 3x is greater than or equal to negative 3x plus 3x. As you can see, the negative 3x and plus 3x, right, that's going to disappear, and we're going to be left with a 0 here. Let's go ahead and collect our like terms up. Our like terms are 2x and 3x, and so that becomes 5x and plus 15. Now I'm going to subtract 15 from both sides because we want to get rid of this 15. So we have 5x plus 15 minus 15 is greater than or equal to minus 15. Right, I'm not going to write the 0 in. So that there's going to disappear, and we're left with 5x is greater than or equal to negative 15. Now I'm going to multiply both sides by 1/5. We've got to get a 1 in front of this x here, and we do that by multiplying through by its reciprocal. So then we're going to be left with x is greater than or equal to, and 15 times 1/5 is just going to be a negative 3. You can also see that 5 goes into 15 3 times. So x is greater than or equal to negative 3. So let me just clear this screen here. Okay. So our solution was x was greater than or equal to negative 3. Now I'm going to draw a number line. I'm going to try to draw a number line anyway. We'll say negative 3 is located here on the number line, and we'll just kind of arbitrarily put 0 over here. And so because this is equal to, I'm going to put a filled in dot. It means we include negative 3, and x is greater than and equal to, so everything to the right of negative 3, including negative 3, would make this, or make our original equation true. Well, it obviously make this true also. So remember that the interval notation, we include negative 3, and we're going to infinity, right? So the bracket, the square bracket here means we include negative 3. So here's two different ways of writing our solution set. Now I'm going to write one in for you, and so that you can solve. So here's your inequality, and you want to come up with, you want to show that x is going to be greater than 7. And remember, we want to write this in a different form, another notation here, this interval notation, and draw your number line. Good luck. Okay, we're working linear inequalities in intermediate algebra. Let's start with 1/5 x plus a half is greater than or equal to 1/10 x. So much like if this were in just an equal sign here, we would solve this linear equation. So what I'm going to do here is I'm going to what should I do? I think I'm going to multiply through by 5 and just get rid of this this 5 here. So let me just do that. I'm going to multiply through each term of this inequality by 5. So 5 times 1/5 is 1, so that's just left with x plus, and then this becomes 5/2 is greater than or equal to 5 times 1/10 is going to be a half. Alright, so I'd just be multiplying 5 times 1/10, and that gives me 1/2x. Now I'm going to go ahead and multiply by 2 to each one of these terms to get rid of this 2 down here in the denominator. So 2 times x is 2x plus 2 times 5/2 is just going to be 5, and 2 times a half is just 1. So that was the whole idea. And now I'm going to subtract x from both sides. So I'm going to go ahead and write that step out. So x minus x is 0. And negative x plus 2x leaves us with an x plus 5. So now what I want to do here is I want to go ahead and subtract 5 from both sides. So we'd be having, let's see, we'd have x plus 5 minus 5 is greater than 0 minus 5, except I'm not going to write the 0 in there. So as you can see, those will cancel out to be 0. And I'm going to go ahead and write this up here. So we'd be left with x is greater than negative 5. Now somewhere in here I just now noticed that I have left off the other part of the inequality. Oop, don't want to do that. So x is greater than or equal to negative 5. So if you were following through, you were probably like, hey, you left that off. Okay, so now I'm going to go ahead and draw my number line so we can kind of get a visual of this. It's not necessary, but we want to do it anyway. So I'm going to go ahead and label negative 5 here on the number line, and I'm just going to arbitrarily put 0 here. Not necessary, but it gives you an idea of kind of where you're at. Now we want to include negative 5, so we're going to put a filled in dot. X is greater than or equal to, so everything to the right of negative 5. I've been doing this in a different color, but hopefully you can see that. Now remember, we've got interval notation also that we can write this out as. So remember, we're including negative 5, so I put a square bracket here. Well, I guess it's time for you to work on one. So let me draw one up on the screen. Okay, so I'll just go ahead and read this off. We have 8 minus 2x is greater than or equal to 2x plus 7. And I guess I'll be nice enough. So that's your goal. You want to try to manipulate this thing down so we get x is less than or equal to a fourth. Make sure you draw your graph and fill it in properly. And go ahead and write out your interval notation. We're talking about linear inequalities in intermediate algebra, and I should have some exercises up by now on my website at mathfix.com. If you would just go to MathFix, click on Intermediate Algebra link, and go to Linear Inequalities on the left-hand side. let's get started. We're going to have 1/5. I think I started out with 1/5 on the last problem. But I'm not working the last problem. Alright, minus 3 is less than or equal to 5/4 minus 3/2 x. Now, I'm going to get rid of these fractions. They drive me crazy. So that's what I'm going to do first. And I'm going to multiply everything through. I'm going to get rid of this 5 here. So I'm going to multiply through by 5 to each one of these terms. And so 5 times 1/5 is going to give me a 1. So we're going to be left with x, because I don't want to write a 1 here, minus 5 times 3 is 15. And 5 times 5/4, multiply 5 times 5 is 25. Fourths minus 5 times 3/2 is 15 over 2. Alright, 5 times 3 is 15. We don't multiply 5 times 2 also down here in the bottom. Sometimes people get that confused and do that. Alright, let me go through now and multiply through by 4 to each one of these terms, and that'll get rid of this 2 here while I'm doing that. So 4 times x is 4x minus 4 times 15 is going to be 60, and of course 4 times 25/4 is just 25. That was the whole idea, to get rid of this 4 down here. Minus now 4 times 15 over 2. If I have a 4 up here in the numerator times 15, we can reduce that. 2 goes into that 4 2 times. And so that ends up becoming 2 times 15, which is 30x. Now I'm going to go ahead and take this 30x and bring it over here to this side of the inequality. And so we have 4x plus 30x minus 60 is less than or equal to 25 minus 30x plus 30x, and so as you can see here, those guys will cancel out. Collecting up like terms here, we have 34x minus 60 is less than or equal to 25. So now we want to take this negative 60 over to the right hand side. I'm going to go ahead and clear this screen. So adding 60 now to both sides, so we have 34x minus 60 plus 60 is less than or equal to 25 plus 60. Those will cancel out, and we're left with 34x is less than or equal to 85. And we multiply both sides by 1 over 34. And we're left with x is less than or equal to, now this will reduce down to 5/2. And remember, we can write that in interval notation and draw our graph. I'm going to go ahead and let you do that. But before I go, I have to state a problem for you. So you want to find the solution set. I'm going to help you out. Right? So you want to try to go from here and get to here. So show that x is greater than negative 12. We are working linear inequalities in intermediate algebra. Okay, so this is just a little bit different than what we've been working. Well, there's really not much to do here. But the way this reads is x is between 3 and 10, x is greater than 3, and x is less than 10. If I were to draw a number line here, and we're going to label 3, and we'll label 10 over here. How's that? Now you notice this doesn't include 3, so I put an open circle here, and it doesn't include 10, open circle, and it's everything in between 3 and 10. So I can pick any number, like for example 5. 5 would be greater than 3 and less than 10, as you can see here. Now there's another way of writing this. You can write this as an interval notation, where you put a parentheses here because we don't include 3, and the 10, and we don't include 10 here. Okay, well, not much is going on with this one, but let's do one where we got to actually do something. What about negative 8? We got less than or equal to a negative x is less than or equal to 2. So in this particular one here, we're going to have to do something. And that is, we just want to get an x right here, just a single x by itself, but we have this negative. And so what I'm going to do here is I'm going to go ahead and multiply through by negative 1 all the way through. And so we'd have negative 1 times negative 8 is less than or equal to, putting this negative 1 in parentheses and the negative x. Usually put everything in parentheses when we're dealing with negatives, so we don't get that confused that it says a minus sign, times 2. But we have to remember, when we multiply through by a negative, we have to flip our inequality. So we want to make sure that we flip this guy here. So that needs to be flipped, right? So flip that like that. So negative 1 times negative 8 is just 8, and negative 1 times negative x is going to be x, and negative 1 times 2 is negative 2. Now this is not the standard way of writing this. We're going to have to flip all this around here, and this states, this should say negative 2 is less than or equal to x, which is less than or equal to 8. Okay, and then we can draw a number line. I'm going to go ahead and put this in interval notation. As you can see here, x has to be between negative 2 and 8, including, we can include negative 2 and include 8. Okay, so I went ahead and drew my graph here, and as you can see, we include negative 2 and 8. We can choose anything in here and plug it in, and we'll get a true statement. Alright, so we got a new one up here. I want to get rid of this negative 4, so I'm going to have to add 4 to each one of these. So this becomes negative 7 plus 4 is less than x minus 4 plus 4 is less than 1 plus 4. So all the way across the board. And so this ends up becoming a negative 2, or negative 3, I'm sorry. X, right, is less than 5. So I go ahead and write this in interval notation, and then I draw a graph, kind of get a representation there visually of what's going on. Now a problem for you. Okay, so you want to show that this inequality up here, show that this is going to be your answer. So I did my interval notation and then drew my graph. Good luck. We're working linear inequalities in intermediate algebra. So we have this inequality and we want to find the solution set. So what I'm going to do here is I'm going to go ahead and subtract 2. We have a positive 2 in here, so I'm going to subtract 2 from everything. So we have 7 minus 2. And minus 2 is less than or equal to 27 minus 2. So now we go ahead and simplify this down. This becomes 5 is less than or equal to, we got a 2 minus 2, which is going to be 0. So this becomes 5x is less than or equal to 25. Now I'm going to go ahead and multiply through everything by 1/5. We want to get a 1 here. And we're going to do that by multiplying through by 1/5. So 1/5 times 5 is less than or equal to 1/5 times 5x is less than or equal to 1/5 times 25. So 1/5 times 5, it just becomes 1. And of course, this is 1/5 times 5. That becomes 1 also. And less than or equal to, 5 goes into 25 5 times. So let me just go ahead and write the interval. X is greater than 1 and less than or equal to 5. So we don't include 1, but we do include 5. And let's go ahead and draw our graph out here. And I'll just put a 1 here. And how about 5 there? Now we don't include 1, so I'm going to put an open circle here, but I'm going to put a closed circle here. And it's everything in between. So we can pick any number between 1 and 5, including 5, but not including 1, right? And plug it in up here, and we should get everything to be true. Alright, wrote a new one up here. Let's work on this guy here. We've got 2 minus 3x in here. And I think what I'm going to do here is I'm going to go ahead and get rid of this 2 by subtracting 2. Alright, minus 2 plus 11. So 5 minus 2 is 3, is less than minus 3x is less than 9. Now we have a negative 3x in here. So I'm going to multiply through by its reciprocal, so negative 1/3. Now remember, we're multiplying through by a negative. So you have to remember that this inequality here is going to be flipped. So we got to keep that in mind. Flipping it. Okay, let's simplify things down. We're going to have a negative 1 is greater than, and this just becomes x, and negative 1 over 3 times 9 is negative 3. So I went ahead and flipped this back around because we want to put our smaller number on the left-hand side always. Okay, and so this way our interval is going to be negative 3 to negative 1. Right, it'd be wrong if I put negative 1 here and a negative 3 there. That'd be totally wrong. And of course, here's our graph. As you can see, we got open circles because of our inequality doesn't include the equal sign. Now, one for you. So here's your problem, and you want to show that this is how you're going to get there. So it's kind of like finding x marks the spot, and you need to find the proper path that will get you to x marks the spot. However, sometimes there's more than one way. Okay, in this section here we got a little twist. We call these compound inequalities that we're going to be working at, still under linear inequalities, but these are known as compound inequalities because and or is going to be introduced. Well, let's get started. So I'm going to write out two separate inequalities. So 3x minus 1 is less than 2, and, I'm going to throw an and in there, and 5x plus 4 is greater than 9. If you hear that chirping in the background, that's some birds. Wish they'd go away. That would drive me crazy. Okay, so we're going to solve these separately here. And so what I'm going to do, just like we've done in the others, I'm going to go ahead and add 1 to both sides. We want to get rid of this 1 here. So we have 3x minus 1 plus 1 is less than 2 plus 1. And so we're going to be left with 3x is less than 3. And of course we're going to multiply both sides by 1/3 because we want to get a 1 here in front of this x. And so we're left with x is less than 1. Okay, well that takes care of this side. Now we need to go over here and work on this side. So we have 5x plus 4. Want to subtract 4. And 9 minus 4. That almost looks like a 7 here, but that's greater than. Okay, and so now we have 5x is greater than, and 9 minus 4 is 5. And then we multiply both sides by 1/5. And so we're left with x is greater than 1. Now let me draw out a graph here so you can see what's going on. X is less than 1, so I'm just going to arbitrarily put 1 right here in the middle and an open circle because we don't include 1. So this means everything less than 1, everything to the left of 1. And this over here means everything to the right of 1. We got this hole here. And means that when I pick a number on the number line, it has to satisfy both this inequality and this inequality. So if I were to choose a number over here on this side and plug it in, it would be good for this guy, but it wouldn't be good for this one over here. So as you can see, there are no numbers, and we have a hole at 1. So there aren't any numbers on the real number line that would make this true and also make this true over here. So the solution set is empty. The solution set is empty, and I can say also this symbol here, which is empty, means empty. The solution set is empty. If you don't understand what all that means, you probably want to go into the sets section and watch some videos on sets. But anyway, there is no solution. Bottom line, there isn't a solution for this compound inequality. Now it's going to be your turn. So we have this compound inequality, and I went ahead and drew a picture down here for you. So you want to try to come up with this down here. Now I'm just going to tell you that it's and, so in other words, a number that you can pick on the number line that's going to satisfy both this inequality and also this inequality here. Well, just by looking at this picture, we can clearly see that there is not going to be a solution. There's not going to be a number we can pick on this number line that's going to make this true and also this true over here. And it's all because of and, right? It must be in this set, and it must satisfy this and this inequality here. But you go ahead, try to work that out, and see if you can come up with this. Okay, we're looking at compound inequalities under the section of linear inequalities and intermediate algebra. And of course you go to my website and find exercises. Just go to intermediate algebra and then look for compound inequalities. Alright, moving right along. So we have this inequality here, I should say compound inequality because of the or. So we want to go through and find the solution for the first one and then the second one, and then we're going to draw out a graph and take a look at what we got. So in this particular one here, I'm going to go ahead and subtract 3 from both sides. So negative 3 plus 3 is going to be 0, so we're going to be left with negative 3x is less than negative 2. Multiplying both sides by the reciprocal of this negative 3 here because we want to get a 1 there. And I think what I'm going to do here is just kind of try to save some room. Ooh. Okay, that's negative 1/3. That's terrible, but we'll write it over here a little better. So we end up with x. Now, because we're multiplying through by a negative, we got to remember to flip this inequality. So this becomes a greater than sign, and negative times a negative is positive. So we got x is greater than 2/3. Now, let's go over here and work on this one. So let's subtract 2 from both sides. So we end up with 5x plus 2 minus 2 is greater than or equal to 2 minus 2. So this is going to end up reducing down to 5x is greater than or equal to 0. And when we multiply through by 1/5 to both sides, which I guess I'll just do right here, we end up with x is greater than or equal to 0. Now remember, we have an or sign, or we have an or. I don't know about the sign, but we've got an or here. Okay, so we got x is greater than 2/3, or x can be greater than or equal to 0. So just by drawing a number line out, I'm going to label 0 here, and remember it's includes 0, so we're going to fill it in there, and it's everything greater than 0. And then of course we have a 2/3 here, and it doesn't include the 2/3. Okay, so how does this work? All right, if I pick a number, it's got to satisfy both this one or this one. So it can satisfy both of them or just one of them. So in other words, I can pick a number, anything greater than or equal to 0, and it will be true for this, well, I should say for this one, anything greater than or equal to 0, but it doesn't have to be satisfy this. So in other words, I can pick a 1 in here, and this would become true, but this not true. But it doesn't matter because it's an or. It's not an and, it's an or. It doesn't make any difference as long as it satisfies one of them. If I were to write this out in interval notation, we would say this right here. Okay, it includes 0 and goes to infinity. Now let me write one up for you. So this is what you got. 6x is less than or 4, or 4x minus 3 is greater than or equal to 7. And I've drawn you a graph. This includes 2/3 and this includes 5/2. So remember, it's or. You can pick something over here, or you could pick something over here. It doesn't matter. Okay, but if this were an and sign, if this were and right here, okay, then this would be no solution. All right, so I'll let you go ahead and work this out and see if you can come up with what I've got here displayed in this graph. We are working linear inequalities, and specifically compound inequalities, where and or has been introduced. All right, let's see what we got here. I got a good one right here for you. 5x minus 2 is less than 4, and 2x plus 7 is greater than 3. So what we're going to do is work on each one of these separately, and let's get rid of this minus 2 in here. Right, so you should know the drill by now. 5x minus 2 plus 2 is less than 4 plus 2. So we're adding 2 to both sides. And we have 5x is less than 6. Now we're going to multiply through by the reciprocal of 5 because we want a 1 here. And so we say 1/5 times 5x is less than 1/5 times 6. And therefore we have x is less than 6/5, and we cannot reduce that down any further. Now let's go over here and look at this inequality. We're going to subtract 7. So 2x plus 7 minus 7 is greater than 3 minus 7. And that's going to leave us with 2x is greater than, and that should become -4 there. So now we want to multiply both sides by a half to get rid of this 2. And so we end up with a half times 2x is greater than a half times, we have the -4. And so now we're left with x is greater than, so a half times -4 is going to be a -2. So x is less than 6/5 and x is greater than -2. Now let me just draw a picture, because a picture is worth 1,000 words, they say. So x is greater than -2. I'm going to label my -2 here, and we'll put 6/5 right out here. Now remember, we're working with and, okay, so we don't want to forget that. X is greater than -2. It doesn't include -2, so we just put an open circle here. And x is less than 6/5. And write another open circle, and everything less than 6/5. So remember, we're working with and means, in a sense, intersection. So that's basically, what do these two intervals have in common? And that's actually going to be the stuff all in between here. So we're looking at between -2 and 6/5. We can't include -2, and we don't include 6/5. It must satisfy both this inequality and this inequality over here. So in a sense, we would say -2 6/5. So we would write this in interval notation, and notice I use the parentheses here because we don't include it. So this would be the solution set that would satisfy both this inequality and this inequality over here. Okay, so this is going to be your problem, and you want to try to reach the actual solution. Remember, we're working with and I've got a graph here for you to use, and you can actually fill this out the appropriate way. All right, good luck.